Hi class, welcome to lesson 10.5. We are using solving quadratic equations by completing the square. Completing the square is a method of solving quadratic equations. Completing the square turns every quadratic equation into the form x squared equals a value. We then can take the square root of both sides and solve for x. Let's look at the first example. In order to complete the square, the first thing we have to understand is what is a perfect square trinomial. Think back to chapter 9 when we talked about the trinomial squared, and we have to FOIL our first, outer, and inner, and last. We can't just square the first term and the second term. Okay, so here we have a trinomial, x squared minus 16x plus c. Think about what c has to be so that this would be a perfect square trinomial. In order to find that c value, one little hint is we can take the c value, we can get the c value by dividing the b value by 2 and squaring it. So if we take 16 and divide it by 2, we get 8, and then we square 8 and we get 64. So we can replace the c with a 64, and we could factor that into x minus 8 quantity squared. Okay, so now we're going to use what we know about perfect squares to solve a quadratic equation. Here we have x squared plus 5x equals 50. Now notice we do not have this equaling 0. It doesn't have to in completing the square. You don't have to have your equation equal to 0. Completing the square is also best used when we have an a value of 1. If we don't have an a value of 1, it's a lot more difficult to get that c value. And so completing the square is best used when your equation doesn't equal 0, when you can't factor it quickly, and when you don't have when your a value is 1. Let's look. So the first thing we're going to do is we're going to write the left side of the equation as a perfect square. So we need to find the c value that we need to add to this side here so that we have a perfect square. So again, we take our b value, which is 5, and divide it by 2, and we get 2.5. We then square that, and we get 6.2, 6.25, sorry, 25 fourths. 5 halves squared is 25 fourths, which is approximately 6.25. So we add 25 fourths to both sides. I'm leaving that as the fraction, and you'll see why here in a second. So we add 25 fourths to both sides of the equation, and we now have x squared plus 5x plus 25 fourths equals 225 fourths. And again, I'm leaving these as fractions, and you'll see why here in a second. So now what we can do is we can factor the left side, and we created a perfect square, so we make sure that we have a perfect square here. We've got x plus 5 halves quantity squared equals 225 over 4. So now what we can do in order to solve is we can take the square root of both sides. If we take the square root of both sides, we get x plus 5 halves equals 15 halves, or x plus 5 halves equals negative 15 halves. So we're going to take the positive and the negative root of this right side. And then we can solve by subtracting 5 halves to both sides, and we get x is 5, or x is negative 10. Go ahead and try the quick check and restart when you're ready. The value of n in order to make this quadratic trinomial a perfect square is 121. If you divide 22 by 2, you get 11, and square it is 121. Example 3, solving a quadratic equation here, but we do have it equal to 0. Now in this case here, we can see that it's going to be hard to factor x squared plus 10x minus 16 equals 0. So what we do is we add 16 to both sides. So we don't have to have our quadratic equation equaling 0 now. And then what we're going to do is we look at the left side here, and we take our 10 and divide it by 2. We get 5, and then square it. So we're going to add 25 to both sides. So we add 25 to both sides, and we're left with x plus 5 quantity squared equals 41. So now we've got a perfect square on the left, and we don't have necessarily a perfect square on the right, which is fine, because we can take the square root of 41. And so we have x plus 5 equals the positive or negative root of 41, which is approximately 6.4. We can then add 5, or subtract 5 from both sides, and then we get 1.4 or negative 11.4. Go ahead and try the quick checks. When you're done, check your work. For number 2, we get 19 and negative 13. And 3, we get negative 0.7 or negative 4.3. And B, we get 12.74 or 1.26. Example 4. Example 4, we are looking at a soccer field, and we have the diagram of the soccer field for a variety of practice drills. The area of the field is 6,000 square yards. What is the value of x? All right, so we have our width as x plus 20, and our length is 2x plus 20. So if we were to find the area of our rectangle, we could take our length times our width equals the area. So we have x plus 20 times 2x plus 20. And if we were to FOIL that, we get 2x squared plus 60x plus 100. So we know that equals 6,000. So we can write our equation. 2x squared plus 60x plus 400 equals 6,000. So now what we're going to do is we're going to subtract 400 from both sides, because we're going to make this a in the form x squared plus bx equals c. We're also going to divide everything by 2 so we can get this to be an a value of 1, because we don't like to use completing the square when our a value isn't 1. So we are going to, here's our equation. We subtracted the 400 from both sides. Then I'm going to take that next step and divide everything by 2. It works out beautifully. Now I look at my b value here, which is 30. Divide it by 2 and square it. That gives us 225. We're then going to write this as a perfect square of x plus 15 quantity squared equals 3,025. We can then take the square root of both sides, and we get x plus 15 equals plus or minus 225. We can then solve using, we can solve equals 55. The square root of 3,025 is 55, because we added 225 to both sides. So now we have x plus 15 equals plus or minus 55. We can get x is 40 or x is negative 70. Because this is a real world problem, we're only going to use the value of 40. Go ahead and try the quick check. When you're ready, check your answers. Here we go. You can see that completing the square is great when the values are not necessarily pretty numbers. They're usually irrational numbers or decimals, and it's hard to factor, and even graphing sometimes will give you some answers that you question. So completing the square is a method to find a lot of irrational answers in quadratic equations. Good luck. We'll do some sample problems in class if you have any questions about these. Thanks.